Back in chapter 1, we did a couple of topics. And one of the topics that we talked about was inverse functions. And I said back then that when we have functions, one of the important ideas with functions is, well, does it have an inverse? Can we find the inverse? We want the function that undoes whatever the function that we have did in the first place. So that's what we're interested in today. Is we want to find the inverse functions of sine function, cosine function, and tangent function. So let me grab a graph. I have a bunch of graphs here. A graph of a sine function. And we're going to take a look at it. There is, let me make that a little bigger. There's a graph, our standard graph of a sine function. Does this pass the vertical line test? Yes. So it is a function, which is good because we've been talking about it as a function for quite a while. Does it pass the horizontal line test? It does not. It fails the horizontal line test. So as it stands right now, the sine function does not have an inverse. But what we're going to do is, because sine function is periodic, what we can do is restrict the domain. So it does have an inverse. We could restrict the domain in several ways, but the way that the conventional way that we do it is, I'm going to highlight this in blue. We're going to restrict the domain to just that portion of the function. And that gets me from pi over 2 here, and I'm at negative pi over 2 here. Does that portion that I've highlighted in blue pass the horizontal line test? Yes. Does that portion in blue contain all the possible y values for the sine function? Yes. Negative 1 to 1, right? So we don't lose anything by cutting off the rest of the sine function. So in between negative pi over 2 and pi over 2, we can define an inverse function. We call that inverse function y equals inverse sine of x, or y equals arc sine of x. And the way that we can think of this is the angle whose sine is x. And in that phrase is the key point for inverse functions, inverse trig functions in general. Inverse trig functions give us an angle. So our normal trig function, we plug in an angle and we get out a number. For the inverse trig functions, we plug in a number and we get out an angle. And for inverse sine, our angle, because we've restricted the domain of our original function, our angle is between negative pi over 2 and pi over 2. Those are the only possible values for the angle that we can get out, because that's where we are here. So when we look for our angle for the inverse sine function, I'm going to draw a little picture. We're looking over here on this half of the unit circle. And the fourth quadrant, in the fourth quadrant, our angles are negative angles, because that's how we've restricted the domain of our original function so that we have an inverse function. So remember the inverse functions switch the domain and the range. So the range of our inverse function is negative pi over 2 to pi over 2. So let me grab a picture of the inverse sine function. I'm not going to expect that we memorize what these graphs of the inverse functions look like. I just want to show us that show us the properties of our inverse functions that we talked about before. This is a reflection over the line y equals x of our original graph. And our x values, our domain is between negative 1 and 1, and our range is between negative pi over 2 and pi over 2. So the key piece of information, big picture about inverse trig functions. Inverse trig functions give us an angle. Second big picture is we have restrictions on the angles that we get out because we had to restrict the domain. Yes?
So the inverse function doesn't have arrows on it. Does that mean
it does not continue? It's only defined from here to here, because what we've done up here is chopped this. We're erasing all of this and all of this. So our sine function, we're just considering that little piece. All right. Questions so far? Yes?
So can I exclude just a sideways sine graph?
Yeah. All right, we're going to do the same thing for cosine and for tangent. So let's look at a cosine graph and talk about how we can get it to have an inverse function. So there's our standard cosine graph. And this is pi. Sorry, that's pi over 2. This is pi. So as it stands here, does this graph pass the horizontal line test? No. Fails the HLT. So this, if we kept our function with all the repeats of the cosine values, we wouldn't have an inverse. We're going to restrict the domain. So it has an inverse. For cosine, we can restrict the domain in a number of different ways. The way that we've traditionally done it is from here to here. So if I look at just that piece of the cosine graph, does that pass the horizontal line test? Yes, it does. And do we get all the possible y values for cosine?
Yes, sir.
There. We get from all the way from +1 to -1. So we get everything we need. So between, yes?
So when we're restricting the domains, is it always going to be from the minimum to the maximum?
Yes. So we're going to say between 0 and pi, we have an inverse function, y equals the inverse cosine of x, or y equals arc cosine x. This is the angle whose cosine is x. And when we're looking for our angle for cosine, we're looking in the top half of the unit circle between 0 and pi. So really what we're doing when we start working on these problems, we're kind of looking at the unit circle kind of in reverse, sort of. All right, so let's look at a graph of this, of an inverse cosine function. There's my graph. And we see that our domain, -1 to 1. So our what we get out of a trig function is a number between -1 and 1. Our range is between 0 and pi. All right, so we're good so far. We're going to do the same thing for the inverse tangent. We can come up with inverse cosecant and inverse secant and inverse cotangent. Things get a little more interesting because we end up splitting up a branch of the cosecant and the secant function to restrict our domain, and it gets a little more complicated. And the main ones that we use are sines, cosines, and tangents. All right, so let's look at graph of our tangent function. We know, just based on how we've graphed our tangent function, that this is definitely not going to pass the horizontal line test because we have all those repeating branches. So this also fails HLT. So without a restriction, this doesn't have an inverse. So we restrict the domain. And for the tangent function, what we do is we restrict the domain just to this one branch. So between, and again, the tangent function takes on all its values here from -infinity to +infinity. So we're not losing anything by cutting it off there. So between -pi/2 and pi/2, we have y equals tangent -1 of x, or y equals arctangent of x. And this is the angle whose tangent is x. And for tangent, just like for sine, we're looking on this half of the unit circle, and the fourth quadrant angles are negative angles. And our inverse tangent graph is here. And we can see that our domain now goes from -infinity to infinity, just like the range did here, and our range between -pi/2 and pi/2. Excuse me. All right, so what I want to do next, well, I'm going to summarize what we've talked about with the domain and the range and that kind of thing, and this piece, the angle whose tangent is x. I'll summarize it in a table, and then we'll do a couple of problems.
Can you go over the quiz as well?
Go over the quiz.
Yeah, 'cause I can see on it.
Graphing, sine, cosine, tangent, cotangent, secant, cosecant.
Alright. Cool, thank you.
Yeah. All right, so here's our function. Oh, and the unit circle also. That's going to be on there.
We should do some examples.
Range. So our function, domain, and our range. Our function, y equals inverse sine of x. And in parentheses, I'm going to put a translation, something that means the same thing. This means the same as sine of y equals x. This is an angle. The sine of the angle is x. This is the angle whose sine is x. They mean the same thing. The domain of the inverse function, -1 to 1. Our sine values for any angle are always between -1 and 1. And our range for the inverse sine, the angle that we get out, is between -pi/2 and pi/2. For our inverse cosine, so y equals inverse cosine x means the same thing as the cosine of y equals x. Our domain, again, -1 to 1. No angle has a cosine smaller than -1 or bigger than 1. Our range for the cosine, where we look for our angles, is between 0 and pi. And finally, our inverse tangent function. This means the same thing as tangent of y equals x. Our domain for inverse tangent is -infinity to infinity. Because a tangent has those vertical asymptotes, that means the inverse tangent is going to have any value that we can put in there. And the angle that we get out, where we look for our angles, is between -pi/2 and pi/2. So really, inverse trig function problems, the way that we'll look at them, are unit circle problems. So I want to look at a few examples. Our homework tonight is pretty straightforward. So I want to look at a couple of examples of using or evaluating inverse trig functions. So your question might be something like this. Find the sine, the exact value, without using your calculator, the inverse sine of -1. So the way to think about this problem, this is the angle between -pi/2 and pi/2, whose sine is -1. So we think, okay, the sine function, that's the y coordinate. So this is saying this angle that I'm looking for has a y coordinate of -1. What angle is that on the negative y-axis? What is it?
270.
And inverse trig functions are always in radians.
3pi/2.
3pi/2, but we want that angle to be between -pi/2 and pi/2. So it would be -pi/2. So 3pi/2 is not between. We want an angle that's the same as 3pi/2 as a negative angle. So this equals -pi/2. And this is the same as saying the sine of -pi/2 equals -1. All right, questions there? So we're looking for angles. We have to think about the coordinate and get the angles. Before we were working with the angle and getting the coordinates. Now we have the coordinate and we want to get the angle. Let's find the arc sine of 1/2. So we're looking for the angle whose sine is 1/2. So the y-coordinate, 1/2. The short side of the 30, 60, 90 triangle. So my little triangles, pi over 6. If you need to draw a little picture, so to visualize it, I'm looking like this. We have the short side of the little triangle. There's 1/2. And this is the same as saying the sine of pi over 6 equals 1/2. How about the inverse cosine of square root of 3 over 2? So, and yeah, that's what I want to do. The pi over 6. It's alongside of the 30, 60, 90 triangle there. The x-coordinate, that's pi over 6. Because that's the same thing as saying the cosine of pi over 6 equals square root of 3 over 2. How about the inverse cosine or the arc cosine of negative 1/2? So now we're looking for the angle whose cosine is negative 1/2. So the x-coordinate is negative. It's the short side of that 30, 60, 90 triangle. 2 pi over 3. Because we're looking between 0 and pi, we're over here. There's my little triangle. We're looking for that length. And this is the same as saying the cosine of 2 pi over 3 is negative 1/2. All right, let me see if I can see how much you've all been paying attention. Inverse sine of square root of 3. First, do we know about how big square root of 3 is? More than square root of 2. How much is square root of 2? 1.4, so it's more than 1.4.
Less than 2, 1.75.
Yeah, it's 1.73, I think. So what does that tell us? What angle has a sine of 1.73? What did you say?
I don't know.
He didn't really say.
I don't
No,
know.
you just made a.
Yeah. I give up. That's my give up.
What angle has a sine of 1.73?
Can we get a hint? Like,
Well, what's? Yeah. So we're talking about sine. Let me go back here.
Yeah, it's more than 1/3. It's like a third and a half.
What angle has a sine of more than? What angle has a sine of 1.73? None. There's no angle that has a sine of square root of 3.
That a kid. Hey, stand up. Come on, stand up. You got it.
So no angle has a sine greater than 1. So this doesn't have this is no solution. Does not exist. No angle has a sine bigger than 1. Mm-hmm.
If like a problem like that's on like I could just do like undefined things that exist or like no.
Either one would be. I'd accept either one.
Okay.
The quiz is not that tricky. I'm not not trying to be that tricky on this. All right, last one. This one's not a tricky one. Inverse tangent of -1. What angle has a tangent of -1? So we know that the sine and the cosine have to be the same, and one of them has to be negative. Pi fourths, the inverse tangent of 1 would be pi fourths. So -1? Negative pi fourths. So we knew it had to be one of the pi fourths angles. We're talking about the fourth quadrant, but we want those angles to be negative. This is the same as saying the tangent of negative pi fourths is -1. All right, so big picture ideas again. Inverse trig functions always in radians, and inverse trig functions are angles. You get an angle out of an inverse trig function. For inverse trig functions, you are looking for angles. Okay. Yes. Did you hear me, Kayla?
I did hear you.
You were trying to act like you didn't?
I just went through my mind.
All right, there we go.